For this one, this is chapter 2, section 1, problem 21, which boundaries have the greatest frequency and which is the has the least frequency. So which data elements here, so these are the frequencies and how often they occurred, how often each occurred, and across the tops is the midpoints. So the midpoint here across the top here, so you can see that midpoint for that greatest frequency, and I'll call that midpoint G. There, midpoint G. And we said that that corresponded here down to 34. And for the least one, you see there, that's the midpoint here. And for the data element, is it the least one? Yeah. Here is 2. 1 halfway, so I'll say that's 1. Okay. That's 1. And what does it occur for? That looks like it's occurring for 16. Okay. So our width in this case here is going to be the difference between the midpoints. Between any two midpoints. And we could choose 13. We could use 19 and 16 here. 19 minus 16 is 3. So my width is equal to 3. So I know the width is 3. Okay. So my lower class boundary is going to be the midpoint minus the width over 2. And my upper class boundary is going to be my midpoint plus the width over 2. So we can run it for both of these scenarios here. So when I have this one, midpoint G so I'll have something like my lower okay. So here I have my formula set up. I know my width is 3. So my lower class boundary would be the midpoint minus the width divided by 2. The upper class boundary is going to be the midpoint plus the width divided by 2. So when I have this midpoint here, G, for the greatest is 34. So my lower class boundary would be 34 minus 1.5, which is 32.5. Then for the upper class boundary, I have the midpoint plus 1.5, which gives me 35.5. So my This is the boundaries here. My boundaries end up being 32.5 minus 35.5. Then you would repeat it again for the second part for the least frequency, where the midpoint is at 16, and you do the same thing again.